Let us see some more examples on steady state error. Consider a unity feedback system. Consider a unity feedback system whose open loop transfer function is G of S equal to K upon S power n, where n is integer. Find the dynamic error coefficients. So f of s we have to find. F of s equal to 1 upon 1 plus G of s. Since it is unity feedback system, that's why H of s equal to 1. That is equal to S power n upon S power n plus k. So what is C naught? C naught equal to limit s tends to 0 f of s. That is equal to 0. Because if you put s equal to 0, it becomes 0. C1 equal to what? C1 equal to limit s tends to 0 d by ds of s power n s power n plus k. That is equal to limit s tends to 0 s power n plus k whole square s power n plus k n s power n minus 1 minus n s power n minus 1 differentiate this denominator and write the numerator as such. So here this is equal to n s power n minus 1 is common. And the remaining s power n plus k minus s power n. S power n plus k whole square. As s tends to 0, here depends upon the value of n, because it is given that n is an integer. It may be 1. If n equal to 1, if n equal to 1, n equal to 1, what is the value? 1 by k. C1 equal to 1 by k. If n is greater than 1, C1 equal to 0. Two cases. C2, we have to find C2. C2 limit s tends to 0 d square ds square s power n upon s power n plus k. That is equal to d by ds limit s tends to 0 d by ds of stake d by ds of n s power n minus 1 k upon s power n plus k whole square. That is equal to, we have to differentiate limit s tends to 0, s power n plus k whole power 4, s power n plus k whole square. If we differentiate the numerator, it becomes k n n minus 1 s power n minus 2. Minus, we have to keep the numerator as such, kn s power n minus 1 2 times s power n plus k. If you differentiate that, s power n minus 1, n into s power n minus 1. That is equal to limit s tends to 0, s power n minus 1 what are the common terms? S power n plus k is common. It is in both. So we can take that out. S power n plus k. Kn also common. Kn also common. This is common. This is common. Okay. N minus 1. S power n minus 2 minus s power n minus 1 2 times s power n minus 1 n also there s power n minus 1. N is taken outside. Okay. S power n plus k to the power 4. In this case, if n equal to 1, you will get one value. If n equal to 2, you will get one value. If greater than 2, you will get one value. If n equal to 1, n equal to 1 means what you will get? And s tends to 0, limit s tends to 0, you will get, this is 1, s power n equal to s plus k, s is 0. So what you will get? K only. Here n equal to 1, this k will be there. K square you will get. Here s equal to 0. So another k you will get. N equal to 1 means this becomes 0. So this entire denominator becomes, this part becomes 0. This n equal to 1 means this becomes 1. This also becomes 1. 1 minus 2. Am I correct? K will be there. N equal to, okay. Upon s becomes 0, s power, okay, k power 4. That is equal to, this is k square, 0 minus 2 divided by k power 4. That is equal to minus 2 by k square. If n equal to 2, if n equal to 2, n equal to 2 means what you will get? K 2, this becomes 0, that's why K, this becomes 0 plus K, 2 minus 1 is 1, this is becomes 1 minus 2 s power 2 minus 1, 0, then 2 minus 1 is 0. 1 K power 4, that is equal to 2K square K cube, 2K cube upon, this is 0, K power 4, that is equal to 2 by K, 2 by K. If n is greater than 2, if n is greater than 2, this is always 0, because if n is greater than 0, greater than 2, this becomes 0 because of this part, entire part is 0. If greater than 2, this part also becomes 0. Therefore, numerator becomes 0. That's why always C2 equal to 0 if n is greater than 2. So if it is integer, we have to consider case wise. N equal to, for C1, if n equal to 1, C1 equal to 1 by k. If n is greater than 1, C1 equal to 0. Similarly, if n equal to 1, C2 equal to minus 2 by k square. If n equal to 2, 2 by k. If n greater than 2, 0. Equal to 0 if n is greater than 2.